All right, as promised, here is the integral for our irreducible quadratic. So remember in class, we got the partial fraction decomposition. We split up our terms. We had to use that linear term because we had a quadratic term that we couldn't factor on the bottom of that second fraction. And in the end, we ended up with our partial fraction decomposition of 1 over x plus 1 plus negative x minus 1 over x squared plus 9. So now when we are asked to find the integral of 10 over x minus 1 times x squared plus 9, we can instead find the integral of 1 over x. And we can already, and I think this is a good idea, split up this integral into two pieces here, our two separate fractions, because the first fraction, that hopefully should be pretty straightforward after the ones that we've seen so far, that we're going to get natural log of the absolute value of x plus 1. The second integral that we're left with, this is a little bit of a pain. We're going to need to split that up into two separate integrals. So we're going to have one of them being, well, maybe we'll go kind of off to the side up here. So what we're going to do is split up that numerator as negative x over x squared plus 9 and then negative 1 over x squared plus 9. So those are going to be our two separate integrals. So we're going to have the integral of negative x over x squared plus 9 and then plus the integral of negative 1 over x squared plus 9. And I kind of sort of have room for my dx off to the side there. We'll scoot down here where we have a little bit more room. We may need to add a little bit more space to this, but we'll see here. So our natural log of the absolute value of x plus 1, that's just going to follow along with us. And then our first integral, we can even kind of write that or split that up even just a little bit more to help us see what we need to do here. This one we can do with a u substitution. If we let u be x squared plus 9, du would be 2x dx, or 1/2 du would be equal to x dx. And then our next integral, I'm actually going to take that negative 1 out and just have 1 over x squared. And I'm going to write my 9 as 3 squared, because what we can use with that one, is 1 over x squared plus a squared. And we have a formula for that. That formula is that the integral of 1 over x squared plus a squared is going to be 1 over a inverse tangent of x over a. So that is what we're going to use. I think we need to grab our spare paper here and see if I can move this. I'll move it. Sorry, you're getting some real time figuring out how to show this problem here. Let's keep scooting that up. We need it a little further up. I think we need it right there. Okay. Yay, that is where we need it. Okay, so we still have our natural log of the absolute value of x plus 1. That part's done. And then we'll do the substitution 1 in orange. So we're going to get, we lost our 1/2. So we're going to get negative 1 times 1/2. That negative 1 came from that negative x right there. And then times 1 over u du. And then plus we have that integral of x squared plus 3 squared dx. And again, we're going to use this formula. So I was just kind of rewriting that so we can now take the integral of each piece. So get natural log of the absolute value of x plus 1. And then minus 1/2, we're going to get natural log of the absolute value of u. And then plus 1/3 inverse tangent of x over 3. We're going to have our plus c, and then we need to do just one little thing. We need to substitute back in for our u. So our whole answer is going to be natural log of the absolute value of x plus 1 minus 1/2 natural log of the absolute value of x squared plus 9, and then plus 1/3 inverse tangent of x over 3 plus c.